like Amy said, I'm Kent Williamson. You heard my bio. I won't get too much into that, but I do want to dive a little bit into my specific part of my past because it plays a big role in why I wrote this book, and also probably intersects with many of your pasts and presents. So again, I'm very honored to be here. I have a lot of admiration for geologists, geoscientists, people that work in this industry. So big honor for me. So I get into it a little bit in the book, but about 20 years ago, I was in a bookstore and I saw a book, and it was The Prize by Daniel Yergin. And at that time, I had no background in oil and gas. I mean, I wasn't totally ignorant, but I picked up the book. I love history and I read it. It's still one of my favorite books. It's published. It's a history of the world oil industry, published over 30 years ago now. So, but I read it and I looked up Daniel Yergin, and he had founded Cambridge Energy Research Associates, CERA, back in the 80s, and then they had been acquired by IHS. And IHS, I had never heard of the company, and I looked them up, and they were based in Denver, which is my hometown. And I was kind of looking around for jobs at the time. And I actually put in some applications. There were some sales jobs. They were in Oklahoma City. And then suddenly one day, I noticed there was a job opening for a product manager here in Tulsa. I was like, okay. And I looked at it. It was for Petra, the geology software. So I'm sure many, if not all of you, have used it or still use it. So they, of course, I had product management experience. I had been a product manager with Hilti, the construction tool and fastener company that our North American headquarters was here. But I didn't have any background in oil and gas or geology or whatever. But I went ahead and put in an application, and wouldn't you know it, I ended up getting the job. So that was in 2007. It was about a year after IHS had acquired GeoPlus, which is the company that produced Petra. So Tom Whitwell was the gentleman that wrote Petra, and then his partner and childhood friend Bob Meyer. So they were the founders, and they had done very well. And they sold to IHS in 2006, and I was the product manager for 4 years, 2007 to 2011. And I ended up spending 15 years with the company. As Amy mentioned, it's now become S&P Global. I moved up to our headquarters at the time in Denver, my hometown. Did a whole bunch of interesting things, and all along the way, I learned all about oil and gas, coal, upstream, midstream, downstream, petrochemicals, electricity, everything adjacent and in between. And so then a few years ago, I left, and I decided to write this book. So that's kind of how I got here. But anyway, those 4 years as the Petra product manager were probably the highlight of my career. It was a really great job. Petra's still out there, amazingly. And I know, many of you are probably still using it. I'm very proud to have been associated with it. So, and again, I really, I may have met some of you in the past at user group meetings or remembered the old IHS regional roundups. So I used to go to those and all that. So good times. And that was a major reason I ended up writing this book. And so, again, I wanted to say I'm really honored to be here talking to you. And I have a really high opinion of what you all do. It's very important. And it's also really cool because you guys are characters in the ongoing saga of American hydrocarbon history. It just keeps going, and it's very fascinating. So this is really exciting. So, another thing I am is that, I was in the military. I'm patriotic. I love the United States. Very proud of it. But I've also always been fascinated by its history. And I've always, especially being in the military and studying the wars and things that we've been in, our military power, I've been fascinated with how did the United States become so powerful. So I always, had a few questions. And of course, at the root of it is the great American people, including you all. But what energized the American people? What helped the United States grow into the greatest industrial and military power that the world has ever known? And what gave the United States the power and endurance to defeat totalitarianism, especially in the 20th century, and usher in an era of unprecedented prosperity? And the answer, a big part of the answer, is hydrocarbons, coal, oil, and natural gas, all of which the United States has huge amounts of. And so, as I mentioned, I learned all about this through my years with IHS. And I also love American history. And so I started looking back at my American history books, and I feel like it's not really covered very well. There are some outstanding books like Dan Jurgens' The Prize, but a lot of them are more academic, or they're focused on one particular hydrocarbon or one era. I was like, we need to know. It's important to know about the history of hydrocarbons from beginning to end, but that's obviously a very expansive subject. You can go any number of directions, and I also know people are not reading as much anymore, and they're definitely not going to be reading 800+ page book like Dan Jurgens' The Prize. So I was like, how do I write a book on this stuff? And what I came up with, it's called Strategic Hydrocarbon Bridges, and I kind of found some discrete geographies and eras in American history where hydrocarbons made physical and time jumps along with American history. So I came up with 15 of them. There's 15 in the book, and that's what the book is structured around. And it starts from early American history all the way to the present day. And I also intersperse some other major historical turning points and events like wars and other stuff to make it interesting. So that's how I wrote the book. It's only about 300 pages, about 100,000 words. I'm not an academic. I'm not a professional historian. And part of why I wrote it was to get the word out to people on this very important topic. And I wrote it in a way, hopefully, and the feedback I've gotten so far, I think I've succeeded pretty well, that experienced people like you would find stuff that you didn't know in it, but also people that have really no industry experience or knowledge would find it interesting and readable. And I think I've done pretty well based on what people have told me so far. So that's the way I ended up writing the book. And so today I'm going to cover a couple strategic hydrocarbon bridges. I'll tell you the names of them a little later, but I picked a couple that are a little bit more obscure. I'm hoping that they're kind of new to you all. It'll be interesting to see how much you know about these. But they're also kind of centered around the late 1800s, early 1900s. And so when the United States is about 100 to 150 years old or so. And they're also connected to a lot of the other ones that you may or may not be more familiar with. So before we get started on the strategic hydrocarbon bridges, let's set the stage, so to speak, and take a quick look at the United States in the late 1800s. And so I've actually tried to choose some photos and pictures that actually have some pretty close connections to hydrocarbons. So late 1800s, of course, we've survived the Civil War and we're in Reconstruction. And that's a picture of a Union ironclad river gunboat, the Cairo class, City class, that's the USS Cairo. Very important in the outcome of the Civil War. Of course, the American Industrial Revolution is in full gear, and factories, iron and steel production, locomotives, all that good stuff. American hydrocarbons, all three of them are off and running. And interestingly, at this point in the 1870s or so, 1880s, they're all the epicenters in Western Pennsylvania and the surrounding Appalachian region. So of course, coal is the most extensively used at this time, and that's actually a picture of a Pittsburgh coal mill. So Pittsburgh is well on its way to becoming the anchor of American industrial power. And then everyone, I'm sure, is familiar with the center picture, the famous Drake Well of 1859 in Titusville, Pennsylvania, the birth of the American oil industry and, in a lot of ways, the world oil industry. And then the lower right, so natural gas has been used on a spotty basis for decades, but it really gets going around late 1870s, early 1880s in Pittsburgh. So they have some huge gas wells, and that's the first major natural gas utility in Pittsburgh. And for a while, it really displaces a lot of coal. It actually cleans up their air for a few years, but then they don't understand the geology and how things work, and it runs out. And I'll get to that. That's kind of a recurring theme in the early years. But that picture is actually George Westinghouse's mansion outside of Pittsburgh, and he actually drilled some natural gas wells basically in his front yard. And they were really productive. And he's better known for his work with electricity, but he had a lot of inventions, patents in natural gas type technology for valves, pipelines, things like that. So those are the hydrocarbons off and running. And of course, the oil industry is dominated outside of upstream E&P by John D. Rockefeller's standard. They control most of the refining, transportation, storage, and marketing. And at this point in the late 1800s, the money is in kerosene, and that's for the humble oil lamp. So it's illumination, and it's sold all over the United States and all over the world. So a lot of people may not know that by the end of the 1800s, we actually exported over 50% of our kerosene production. So it was a worldwide phenomenon. That's where the money was. There were other products, which we'll get into a few, but kerosene was where the money was. So a few other things about late 1800s USA. Of course, the frontier is closing by around 1890. We've expanded to the Pacific coast. There's the California Republic. So California has been a state since 1850. I'll talk about that more a little bit later as well. And though we're still a primarily Atlantic and Europe facing country, we're becoming more Pacific facing. So that's a picture of the famous opening of Japan by the US Navy in 1853. And of course, we also have Alaska, Hawaii by the very end of the 1800s, and then our colonial possessions from the Spanish-American War. So the United States has expanded out to what would become its greatest geographic extent at the end of the 1800s. And of course, we're at the dawn of the age of electricity and the internal combustion engine and the automobile. So on the left, of course, is Thomas Edison and his light bulb, but he also set up the first electric network in New York in the early 1880s, fueled by a coal-powered generator. And then that's Henry Ford on his quadricycle. He would become much more important in the early 1900s, especially with the Model T. So to summarize the late 1800s United States, I really love these two kind of bookend pictures here. So on the left is the Corliss Centennial engine at the 1876 Centennial Exposition in Philadelphia, celebrating 100 years of nationhood. And it's actually, I used a picture of that on the cover of my book. So I'm totally fascinated with that thing. I would love to have seen that thing operating in person. Keep in mind, this is a few years before electricity. That thing ran the whole show for 6 months. Of course, it was fueled by coal. But pretty awesome steam engine, like 45 feet high, running. And that thing, it ended up going to the Pullman Railroad Car Company after and ran for like 30 years till like 1910. So it was a good piece of gear. And then on the right is another Corliss steam engine. That one was built by Alice, and it powered electrical generators and dynamo. And so I love this quote. This was by a historian, Henry Adams, and he was actually observing that steam engine at the Chicago World's Fair. And what's really cool, this is actually in the book, but I just love the term "pour coal hidden in a dirty engine house, carefully kept out of sight." So, and I think that's emblematic of hydrocarbons in general. It's like, you know, so many people, including myself when I was younger, it's like you flick on the lights or you pull up your car, get on a jet airplane and use some plastic or whatever. You don't realize where it's coming from, how it's produced. And so it's kind of hidden in a dirty engine house, carefully kept out of sight. I love that quote. So one of the things I mentioned is Pittsburgh has this natural gas boom. And though it's an interesting story. It did run out, but while they used it, it was very effective. So people were on the lookout for natural gas. And in one area they found it was Lima, Ohio. So this gentleman, they were looking for it, Benjamin Farrat, or Farrow, I'm not sure how it's pronounced, but he had a paper mill in Lima, Ohio, and he drilled a well for natural gas and wanted to use for his paper mill, but he found oil instead. So thus was born in 1885 the Lima field, the great Lima oil boom. And I love that postcard because, you know, it shows, it's so funny because it shows a gusher and then a tank fire. It's like, man, you wouldn't do that to this day and age. They were like proud of that stuff back then. You know, it's like, we got it going on. We got an oil field going here. So, but there was one problem with this oil. It was full of sulfur and it stunk. They called it skunk oil. So it was heavy, sour crude. And at the time, the refining methods could not refine that into the moneymaker of the day was kerosene. Obviously, You can't burn lamp oil in a house with sulfur in it. It stinks it up. It's intolerable. So that, what was going to be done with it? So in steps Herman Frasch, and he was later known as the Sulfur King. So he had actually worked for Standard Oil. He had left, and then he had patented some desulfurization techniques and technology. And when Standard was heavily involved in the Lima oil fields because it was pretty close to Cleveland, they typically avoided upstream, but they got into this one. And they quickly brought him back on, and they built a refinery in Whiting, Indiana, near Chicago. That refinery still exists to this day, it's owned by BP. They built a pipeline from the Lima oil fields to that refinery, and Frasch and his team made very important advancements in desulfurization of heavy crude. You guys all know how important that is, given how much heavy sour or other sour types of crudes are out there, from Canada to Latin America, even the Middle East, and the U.S. Gulf Coast, California, and elsewhere. So very important. So Herman, the Sulfur King Frasch, he got rid of the skunk and the skunk oil. And I don't know if he came up with the Sulfur King nickname or someone else did, but he apparently embraced it. It was kind of his brand. And I would imagine if he was around today, his Twitter handle would be @the_Sulfur_King or maybe @the_Skunk_Oil_Slayer or something like that. So, and he's a pretty stylish dude too. So Herman Frasch. So another product that really came to the fore out of the Lima oil boom, and I like to call fuel oil the coal of the petroleum products. It's kind of overlooked, it's dirty, nasty. There's different kinds of fuel oil out there, but it's important. And throughout history, and we're still using it today. It's always overshadowed by kerosene or gasoline or jet fuel or whatever. But the sheer volume of this oil, especially before they could get the sulfur out of it, something had to be done with it. We know Standard never wasted an opportunity to make money. And so they started, and they had a huge marketing and distribution machine. So they started shipping it around, especially in growing Midwest industrial cities like Cleveland, Detroit, Chicago, to replace coal. And that's actually a quote out of one of their marketing brochures. So it's basically features and benefits of fuel oil over coal. And take a look at that. And then if you think forward a little bit, natural gas has some of the same advantages over fuel oil and coal. So you can see kind of the evolution of where we're going. But that's a picture of a Joshua Hendy triple expansion marine steam engine, a reciprocating steam engine, very important in American history. So that's a World War I version. Those would go on to be put on the famous Liberty ships of World War II, the ones that we pumped out like day after day, and that were super important for logistics during World War II. They were very reliable and they ran on fuel oil. And to this day, keep in mind, the U.S. Navy, even though we have nuclear aircraft carriers and nuclear submarines, most of the fleet still runs on fuel oil. It's actually kind of a fuel oil distillate hybrid. It's a NATO standard fuel, but to this day, we're still using it. So pretty important stuff. So what happens that there people continue looking for oil, and one place they drill is in Findlay, Ohio, just up the road from Lima. And this time someone finds natural gas instead of oil. And Findlay happens to be the current headquarters of Marathon Petroleum, which I'll get to a little bit later. But the Great Cardwell blew out. It was way too powerful for any kind of well control they had at that time. And then it ignited and it burned for like 4 months. And it was like a huge tourist attraction. You can see the picture. But it touched off a natural gas grid. It turned out most of the natural gas was in East Central Indiana. So that's an exhibition that Indiana would do these to attract businesses and people, and they're basically just flaring gas. And that over there is Findlay, Ohio. So those lights are called flambeaux. And what towns all over the region would just use natural gas, and they were fancy gas lights, and they would use them for decoration, for illumination, and marketing purposes. So the bottom line is, much like in Pittsburgh, they didn't understand, the geology and how natural gas worked. I think, they thought it was just spewing out to the center of the earth and it was inexhaustible. So there was a lot of waste, and there was a lot of other factors involved. But it did touch off a strong economic boom in Indiana and Ohio. a lot of businesses, especially the glass business in Ohio, some of which are still there, came in. And it again demonstrated that natural gas, if you could get it at a reasonable price and have the infrastructure, it was a superior fuel to the others for a lot of applications. It did start running out. Oh, the other thing they did is Indiana, they ran a then long distance natural gas pipeline from Indiana to Chicago in early 1890s. And Chicago went off manufactured gas based on coal to natural gas. But then the gas started running out in the early 1900s, and Chicago actually had to switch back to manufactured gas based on coal. So it did give the natural gas industry a bit of a black eye, but it showed that if it was there and available, it was really good. And then Standard had a subsidiary called Hope Natural Gas, and they had some big wells down in West Virginia, and they started building pipelines into Ohio. So you can see, instead of isolated cities, you're starting to see the formation in the early 1900s of a regional natural gas network, which would become important. So that's the Indiana gas boom, and this is our first strategic hydrocarbon bridge, so the Midwest Oil and Natural Gas Bridge. I call it the bridge between hydrocarbon bridges, because the earlier ones, if you read the book, there's earlier ones to the east that are based more on coal and the early oil and gas industry, and then later on, of course, the great Gulf Coast and mid-continent oil and gas discoveries. So and I love how kind of concise it is. It's right there between Appalachia to the east and Chicago and the agricultural hinterland and the Mississippi Valley to the west, the Great Lakes to the north, and the Ohio River Valley to the south. So that's our first strategic hydrocarbon bridge. Excuse me. So the next one we'll move into, but the next one has a connection to a company that grew out of this strategic hydrocarbon bridge, specifically the Lima oil field. So the Ohio Oil Company, it grew out of the Lima oil boom. It was founded in 1887. It was founded by a group of people that wanted to keep it separate from Standard. And there was a lot of that in those early years. And 2 years later, they sold out to Standard. So it became part of Standard until 1911, when Standard was broken up. And then it became the Ohio Oil Company again. And it was exploring all over the place, including in what's now the Permian Basin, West Texas, in the 1920s, just getting started. So they partnered up with a cash poor company called the Transcontinental Oil Company. And incidentally, that company had this marathon logo, the marathon runner. So eventually, Ohio Oil Company bought Transcontinental, and then years later, it morphed into Marathon Oil. And of course, the downstream portion of that, Marathon Petroleum, is based in Findlay, Ohio, the site of the great carb well that touched off Indiana National Gas boom. So there's a Yates field drilling crew in the 1920s. By the end of the 1920s, the Permian Basin is booming. And like many other places, it's producing a lot of natural gas. And that place, even today, is isolated. But back then, it was like out in the middle of nowhere. So, of course, all the natural gas is basically being flared and wasted. So one man saw an opportunity, and I'll get to him in a little bit. First, we need to step back in history a little bit. California and the Gadsden Purchase. So California becomes part of the United States after the Mexican-American War in 1848. And of course, the great California gold rush of 1849, so people start streaming in, and then California becomes a state shortly thereafter in 1850. Most people initially come in through San Francisco. So, they're looking for gold, and San Francisco becomes the first kind of boom town in California. And one gentleman who came to mine gold, make his fortune in gold like many others, had to find something else to do. He ended up starting a manufactured gas lighting company. And that's the forebear to the modern day California utilities. And it used coal, but California has basically no coal. So they had to import the coal, including from Pennsylvania and Australia and elsewhere. Of course, that's expensive. So a recurring theme to this is, keep in mind, is in California, they're always looking for a substitute for coal. And then the Gadsden Purchase. So this is kind of one of the more obscure territorial acquisitions in U.S. history, and it actually filled out the full map of the lower 48, 1853. And it's kind of an outgrowth of the Mexican-American War. But it was really, we bought it from Mexico because it was needed for a railroad, basically. There was a few other reasons. But you may remember from your history, high school history or whatever, there was a real push to do transcontinental railroads in the 1850s. And there was a sectional competition between the North and the South. And of course, the southern states wanted it through Texas and down to Southern California. So the Gadsden Purchase was supposed to be a railroad route, and it did become one, so the Southern Pacific Railroad. What happened is the Civil War intervened, and the Transcontinental Railroad ended up being on the more central route into Northern California. But after the Civil War, the Southern Pacific Railroad was incorporated in California. It built out in California for the first years, and then eventually by the 1880s, it extends into Texas and Louisiana. And so keep that. That's one of their steam locomotives, and that actually runs on fuel. And I'll get to why that is here shortly. So the California and the Gadsden Purchase. So I apologize for this busy slide, but California was one of the more challenging things to write about in this book because it's kind of off on its own the whole time. So what happens is the railroads, one of the first boons in Southern California is the railroads start shipping oranges in refrigerated rail cars in the 1880s. And that got Los Angeles, of course, Orange County, California going. So a boom happens, but what really got California going, especially Southern California, is oil. And oil, of course, was well known in California. The La Brea tar pits, oil seeps all over the place, so people had known about it for hundreds of years. And there was small-scale production and refining going back to the 1860s, but it was very localized and small. But in 1892 is the great Los Angeles City oil field. So it's kind of interesting to think it's really right about the same time as the Lima oil field, Indiana natural gas field that are going on across the country. And the gentleman that discovered it is Edward Doheny down in the lower left. So he would go on to found the Pan American Oil Company, which became an iconic American and international oil company in the early to mid 1900s. And as an aside, if you've seen this movie, There Will Be Blood, it stars Daniel Day-Lewis as Daniel Plainview. And it's loosely based on a novel by Upton Sinclair called Oil. But most things I've read is Plainview is somewhat based on Edward Doheny. And I kind of agree with that, but I've also kind of done some subsequent research, and I think he's kind of a composite of several different people in California oil history, including Lyman Stewart, who founded Union Oil California. And that became another iconic American and international oil company. So, and then like Lima, most of the crude in California is headed south. So it's hard to refine. So I'm sure a lot of the Sulfur Kings techniques were used, but there's also a lot of important refining advancements. And I love these guys. This is Jesse Doves and his son, Carbon Petroleum Doves. So old Jesse loved the oil business so much that he named his son Carbon Petroleum. But I guess he went by CP Doves through most of his life. But these guys made some serious advancements to the Doves process, and they were like asphalted crude specialists. So California crude is asphalt, a lot of it's asphalted. And you can imagine how important that was at this time in history. So the automobiles taking off, the highway network. So refining asphalt out of crude becomes very important, and being able to refine it into other products as well. And they basically are the forebears to what became Universal Oil Products, or UOP, which is now Honeywell UOP. So, and I know I'm talking to a room full of geologists, so I can't go without talking about a geologist. But you know, you guys are probably well aware petroleum geology is still in its infancy at this point. You know, most exploration is corsology or looking for oil sweeps, or even using the whatchamacallit sticks. Yeah, so, but there's this gentleman is really interesting. His name is E.T. Dumble. And so the Southern Pacific Railroad, so all the railroads got these alternating land grants, including mineral rights. Southern Pacific had a bunch of land in the San Joaquin Valley of California and the Gulf Coast of Texas with a lot of oil and gas. So they had their own oil companies, and that is partly to make money, but it was also, as I mentioned, they switched over from coal to fuel oil for their steam locomotives. And so this guy, E.T. Dumble, Southern Pacific Railway, was one of the first companies to have a dedicated geology department for exploration and production, and he was the head of it. Now, he had been the state geologist for Texas in the 1880s and 1890s. Really interesting guy, but he did a lot of groundbreaking work, including in micropaleontology and so forth. And he wasn't a one-trick pony as far as hydrocarbons go. He had done an extensive study of Texas's lignite coal deposits as well. So, really fascinating dude. E.T. Dumble, an early geologist in the oil business. So California starts growing. It's got a lot of oil, a lot of people coming in, and it's got great weather and a lot of other attributes, and it's growing economically. It keeps growing even through the Great Depression. So we all know about the Okies and the grapes of wrath and all that. But then California is critical in World War II. So the aviation industry becomes based in Southern California primarily. And during World War II, that is a key strategic advantage for the United States. A lot of shipbuilding in California too. So it's using tons of oil, it's exporting tons of oil, and it's using its natural gas. So Los Angeles switches over to natural gas in 1913. San Francisco in the 1920s, so decades before like major East Coast and Midwest cities. But as they're approaching World War II, when they get into World War II, they know they're going to need it from somewhere else. So where are they going to get it? Well, that takes us back to the Permian Basin. And the man that I mentioned a few minutes ago, his name is Paul Kaiser. So who's even heard of this guy? He was a Houston lawyer and a businessman, and he had been out in the Permian Basin, I think, looking to set up an oil company, but he noticed all the flaring. And then somehow he figured out that El Paso, Texas did not have natural gas service. So he came up with the idea to build a pipeline and provide El Paso, Texas with natural gas. And so right here, it initially started down here in southeastern New Mexico, the tiny town of Jal, New Mexico. They piped gas to El Paso, and then through the 30s, it extends through southern New Mexico and into southern Arizona. Again, the Gadsden Purchase. And critically in southern Arizona, you may know that was then and remains the leading American copper producing region. So that natural gas is perfect for copper smelting, especially in a region without oil or coal that has to be railed in expensively. So this cheap natural gas by pipeline is a godsend for the copper industry. And of course, copper was extremely important at that time as we're electrifying. And then Southern California becomes the center of the aviation industry. Aircraft take a huge amount of copper for wiring and other stuff. So really important. The pipelines extend into northern Mexico, which they still do today, and to the growing cities of Tucson and Phoenix. However, World War II intervenes and the pipeline stays kind of where it is for a while. But then after World War II, the California is continuing to grow. They need more natural gas. And then at the same time, Texas starts cracking down on gas flaring and gas waste. So all the producers in the Permian are basically looking for someone to take their gas, and Paul Kaiser's El Paso natural gas is where it goes. So he extends those pipelines all into the Permian Basin, even up into the panhandle of Texas. And they connect up in 1947 with pipelines from the Southern California Gas Company and start supplying California with gas. And then later in the 50s, they extend up to Northern California. And El Paso has to tap the San Juan Basin of southwestern Colorado and northwestern New Mexico. So that is now owned by Kinder Morgan. In fact, that's where I got this map. Still going, and they're now looking to expand it even further. Of course, with all the natural gas still coming out of the Permian Basin. Another interesting thing I always thought about with the San Juan is I remember when I was the petroproduct manager, we had some projects, some demo projects there. But that was a early part of the unconventional revolution, was the coal seam gas up there. Pretty cool on the hydrocarbon synergy. So Paul Kaiser and El Paso Natural Gas, and I give you the Texas and New Mexico to California Natural Gas Bridge. So I kind of struggle with this one because I could have put oil in there too, because it was oil in California and oil in the Permian Basin that produced this natural gas. But really, the natural gas was what moved between the two regions. And keep in mind, basically by 1947, now the natural gas pipeline system extends from coast to coast to coast, basically. The East Coast, the Gulf Coast, and the West Coast. So very interesting hydrocarbon bridge. So that brings us to the end of the talk. So I wanted to kind of summarize the importance of these strategic hydrocarbon bridges. They are kind of obscure. They're not as famous as some of the major oil strikes or the major coal mining in the East Coast area, but they're very important because especially the timing and the geography. So you have as far as the oil industry goes, you have the Pennsylvania oil fields to get things started. That's mostly kind of light sweet crude. That's, just think of in the 1880s, it's like heavy sour right there. And I'm sure someone would have figured out desulfurization at some point, but the fact that it happened right then in Herman, the Sulphur King crashes there, and it forced our industry to address that. And then it extended the oil industry into the Midwest by Chicago with the Whiting refinery. And that refinery would later be the site of important thermal cracking advances in the early 1900s for producing more gasoline as the automobile revolution takes off. And then, of course, the natural gas industry also extends out. As I mentioned, there's kind of the nascent regional natural gas network around Appalachian and Midwest. And then California is important as well as an industrial center and for refining advances and so forth. And connecting to that is very important. And of course, today we're kind of back in those areas, interestingly. So in Ohio with the unconventional revolution, the Utica Shale, and so forth. And then California, I won't get into that whole subject, but what's interesting about it is now we have, with the Permian Basin supplying 40% of our oil and amazingly 20% of our natural gas, looking to get the natural gas pretty much anywhere. LNG exports from the Gulf Coast. But as I mentioned, there are some companies are going to expand pipelines into Arizona and California. But another kind of interesting reversal of history or twist in history is California's refineries are shutting down. So Phillips 66 is closing their Los Angeles area refinery, so Phillips 66 with Oklahoma roots. And then Valero is closing their one up in the San Francisco area. So where's California going to get its refined products? Well, now what's interesting is Phillips 66 and Kinder Morgan are going to reverse some historic refined product pipelines and then basically pipe it from the Midwest, including historic refineries in Ponca City and Borger, Texas, into Arizona and California. And then HF Sinclair, so another company with Tulsa and Oklahoma roots and a presence, that refinery over across the river, they are going to expand pipelines from Utah down into Nevada. So it's like, I don't personally like what's going on in California. I think they're heading in the wrong path in a lot of ways, but it's also fascinating to see how our amazing oil and natural gas pipeline network and all that infrastructure that's been built up over the last almost 150 years is able to adapt. And so, California, they may have to shut down refineries, but we'll just pipe the refined product from somewhere else and bring it in as long as they need it. So pretty interesting stuff. So I appreciate you inviting me here today. Again, I'm honored. I appreciate the work you guys do. And I'm in awe of your skills, being able to find oil and natural gas. And I love working with people like you when I was the petroproduct manager. So that's part of what inspired me to write this book. And I think, it's important that people understand the history of it, because it's really important to what America has become today. And so it's available on Amazon and paperback and ebook. I'm coming out with an audiobook soon. So again, I tried to make it manageable. It's not that long. And also, since we're coming up on Christmas, keep this in mind. You may have friends or family that have a lot of misconceptions about hydrocarbons or oil and gas or whatever. or some of them may actually dislike what you do, or think it's all bad for the planet or whatever. So you're thinking maybe a little more of a provocative gift for someone, consider buying it. And if you're around, I'm here local in Tulsa. If you buy it, I'd be happy to, you can get my contact info through Amy. I'd be happy to sign it for you or whatever. And one last thing, I just want to give a shout out to this organization, American Oil and Gas Historical Society. So I cited it pretty heavily in my book. They have a really cool website. You can sign up for a weekly email. It's a guy named Bruce Wells who runs it. It's out of Virginia. He does a really good job of, if you love the industry and you love the history, it's really interesting stuff. Very readable little articles and updates and stuff like that. So, and they take donations. Kind of interesting. And I use some of their photos for this presentation. So with that, if you guys have any questions, happy to answer those. And if not, I have a slideshow, American hydrocarbon history related trip I took that I can show you if you're interested.
Yeah, I have two comments. One was on that slide on the skunk oil.
On the what? Skunk oil? Okay.
Yeah, right. Yeah, the engineer there, Trash.
Yes.
How do you call it, the title sulfur thing back in the late 1880s? He devised a method of using injection wells. Where they would target salt domes on the Gulf Coast, starting in Louisiana, South Louisiana, with the injection wells and the drill into the Capital, which had large deposits of sulfur, inject superheated steam. Now when it comes to the surface, and then you just take that from salt dome to salt dome, and some of those salt domes have, to this day, still have like the largest deposits of sulfur.
Yeah, I do. I mean, I did not know that. But I do know, I remember reading that he did later move down to the Gulf Coast and doing stuff down there.
And then second comment, and maybe in your text, you probably wasn't on your slide. Do you address the Bradford oil study?
I mentioned it, yeah. I mean, again, this is pretty high level, but it's, that was kind of the first major oil field on the original, outside of the Titusville core. And there were some different types of crude, so forth.
Yeah, I think you would use that one as sort of so-called, bridge. That going into
Yes, it definitely was. I did gloss over Bradford, but what was interesting, so I cover since we're talking about pipelines. So they had some small scale gathering pipelines and things like that. They tried to build some longer distance pipelines because back then the only way you could get the oil out was on wagons. They did have railroad connections, but Standard kind of dominated the railroad. Then they could ship some down the Allegheny River on barges and stuff to Pittsburgh. So different groups tried to build pipelines to bypass some of the bottlenecks. The first group that succeeded, it was called the Tidewater Pipeline. And it started up near the Bradford field, and it ran down to Williamsport, Pennsylvania, the site of the Little League World Series. And so they succeeded. It was actually a lot of cloak and dagger stuff. Standard tried to stop them, and then Standard eventually kind of overwhelmed them anyway, and kind of came to an agreement with them. But it was kind of a cool story. But that was one connection covered related to Bradford.
What's interesting about Bradford was after the major oil companies thought they got as much oil as possible, they left. And then an independent forest oil.
Yes.
They went in there, bought all the leases, and applied the first commercial large scale water flood.
That's right.
And from that water flood project, it produced more oil than before. And this total production made that the first giant oil field.
Yes. And that's that's another thing that really inspired me on this book. So back to my petrochemical manager days, I didn't have a background in industry, so I came in, and one of Petra's strengths was its ability to handle a lot of wells. And so when I got in there and I started learning, I was like, why are there so many wells? In fact, I remember we went down and visited this guy in Houston, and that he had a 64-bit desktop, which super powerful and wasn't hooked up to the network. It was just standalone. he had a petro project with every well in the United States. It's like 4 million wells. And he would like zoom in and zoom out. And it was like, really cool. But I asked him, why are there so many wells in the United States? And it's, because of the private mineral rights we have here. People we're basically the only country in the world that's true. And so that is going to now it led to a lot of kind of chaotic development and waste, but it also led to a very dynamic industry. So it's really fascinating. But that water flood with forest oil is a really great example. We continue to see that over and over and over. These oil fields are left for dead, and someone comes in and figures out a way to get more oil and gas. Fracking, that stuff, water floods, steam floods. So another petro project we always had was the Midway Sunset Field. The steam flooding out there. So we actually had an engineer, so I'll give a plug for his book. His name's Steve Moore, and he's local here. He would work for us for a while, and he was helping build out Petro's petroleum engineering functionality. But he went to the University of Tulsa. He started his career out in Bakersfield. He was doing all those heavy oil fields, doing the steam floods out there. But he's written a book on his career that's pretty funny. It's called Plugged and Abandoned. I've read it. It's actually I really like it. I mean, I've never really read anything like it, but I recommend it if you like a humorous view to the oil industry. But he's a novelist, so he has some science fiction novels that he's writing too. So look up Steve Moore if you like reading that kind of stuff. But that was one of the fun things that I learned too was with Petro was, it was written by a geologist, so Tom Whitlow was a geologist. And it was for geologists primarily, but it became used by so many different people, including engineers. And I always got a kick out of that because, it was great for engineers, and I think it was great for productivity, but geologists didn't really like it. A lot of things. They didn't like engineers getting involved in there. And there was always that mystery where they could kind of keep the engineers at arm's length because they did the share stuff. And then engineers with Petro could get into it. So there's always that interesting kind of rivalry, friction. But overall, I think it worked out all right. We got a kick out of that. So,
what's the driver of this? Refineries being closed in California.
Well, they're just, California, state of California is very hostile towards hydrocarbons.
Primarily hostility.
Yes. And so they have, there are unique, the California's climate and their geography is, air pollution was a very serious problem and still is to an extent because of the valleys and the number of people out there. I mean, Los Angeles area is like 20 million people. So they do have, legitimate concerns, but, and they have their own standard for gasoline. So, these
be tighter.
Yeah.
Restricted more.
So there's refining is a game of economies of scale. And at a certain point, you can't, just make endless varieties of gasoline. But they're very hostile. They have a lot of regulations and taxes, and they won't let companies do things. And so these companies they're just like, well, we're not going to. And refineries, they take a lot of money to keep up. You have to put in new units. It's years or decades paybacks. So these companies are not going to sit there and be under attack and invest millions or billions of dollars in refineries. So that's Phillips 66 and Valero closing down. But
A comment and then a question. Daniel Jurgen has written a sequel to the prize.
Yes.
In energy.
2 sequels, actually.
Well, okay, at least 2 sequels. When will the audio version be ready?
The audiobook for this one, hopefully in the next couple weeks.
Okay.
And I narrated it myself. So.
Oh, you do?
It'll be a little rough around the edges. I found a neat little studio here in town. A young guy who does mostly musical production, but he does audiobooks. So he had all the equipment, did all the tech stuff, and I just read it. But man, you'd be surprised how much it's actually pretty tough to read a book and try to not sound like a robot, and then but also pronounce things correctly and keep going. It's pretty difficult. So another option I'll throw out there.
I'll give you a good compliment on that, because of the slips that I've read, it's really neat to hear the author's book, especially when I know the author.
Yeah, I'll be interested to see what people think of my voice and all that. But another option that's really funny is, so, if you get the ebook, you can get these AI, things, so Speechify is one, there's others out there, but I did a trial of Speechify. And it's pretty uncanny. So I did it, and they have different voices you can choose, including celebrity voices, and they have Snoop Dogg. And so I had AI Snoop read parts of my book, and it actually sounds just like it. Now, what happens is the pronunciation and the tone kind of get off filter. So, you can tell it's not a human, but it's still pretty uncanny how much it sounds like Snoop reading my book.
There's a way to appeal to the young people.
Yeah.
The Snoop version.
That's another option if you are so inclined. Any other questions?
I have a question. It sounds like the history is also connected, and I think you mentioned it, to pipeline industry. So I'm curious if alongside refinement, were different ways that the pipeline technologies would be created. And then you mentioned that they're going to have to revisit some of the pipeline back to California. What new technologies in pipeline did your book mention, or are they even if it's determined, will they be more efficient nowadays than what they were? And do we still have the historical, like the old London Underground? Do we still have the old pipe maps that exist? What do we do with them, even if they're not being utilized?
So, yeah, I covered the pipeline system pretty extensively. Now, again, it's a high level view. So, but I get into quite a bit of, some key technology type stuff. So I mentioned George Westinghouse and others, they came up with, so a big problem was leakage. And that could be quite dangerous too. So, and then valve technology, so Westinghouse came up with some of that. But compression technology, and then gas processing technology is very important, because as you all know, I didn't mention it so much today, but NGLs are a huge part of our output now, very important. But back in the 1800s, they didn't understand that. And so NGLs or LPG were just kind of these mysterious volatile fractions that cause explosions, things like that. But actually building long distance pipelines was very difficult, and it wasn't possible for a long time. I mentioned that about 100-mile one from Indiana, but the real long distance ones, like approaching 1,000 miles, were in the 1920s. And they were from the Panhandle field in North Texas and the Huberton field in Southwest Kansas, and they went back into the Midwest. Well, part of the reason they could do that at that time, because pipe manufacture, like other things, it took a long time to figure out how to manufacture pipes of certain lengths. So if you try to build a super long distance pipeline with real short lengths of pipe, it's uneconomic. But then there's welding techniques, both in the manufacturing and in the field, took time to develop. So electric arc welding, become, of course, it's called the age of electricity. But that wasn't effective until you had economic kind of generators to generate the electricity, and that was possible, became possible with gasoline and diesel and things like that. So all that kind of stuff, pipe joining and then pipe laying. And so there's a great company right here in town, Williamson. So they go back over 100 years, and they were key contributors to pipeline construction techniques. So trenching, laying pipes, they developed special machines for all that. And then you mentioned decommissioned pipelines. So that's what's fascinating, is a lot of them can just be repurposed. So a lot of pipelines have been used for crude oil, refined products, and natural gas. And they go back and forth sometimes. Yes. So I was going to mention that Williams pioneered in the 80s laying fiber optic lines through decommissioned pipelines. So yeah, all that kind of stuff is really interesting. So I'm sure there's a lot, especially smaller diameter pipeline is just underground now. There may be some that we don't even know it's there, but there is a lot that we know is there and can be used for that. So. Well, yeah, that, the pipelines, I just love that stuff. And it's just amazing how to this day, you know, they're constantly building new connections, reversing pipelines. And, because now you've got LNG exports, crude exports, and trying to get stuff to different, you know, the other big thing, of course, is the natural gas, maybe the Marcellus Shale, Appalachian. So all the pipelines were shipping gas northeast. And that thing came out, we had to like replumb our whole gas pipeline system. A lot of it's going back to the west. Yeah, when I started with Petra, that was, remember the Rockies Express pipeline? That was like the big talk of the industry. Like it was going all the way from Colorado or Wyoming, all the way out into Ohio. And then right as it got out there, that's when Marcellus Shale got going. And so now it's sending natural gas to everything. Yeah, so but it is pretty interesting how they can do all that stuff. So, yeah, pipes are fascinating. All the subsea type pipes and stuff they do, you know, offshore is really fascinating too. And then I get into the Trans-Alaska pipeline. So I have a hydrocarbon bridge that involves Alaska and offshore Gulf of Mexico. But that was a feat of engineering in itself. And so they had to run it on stilts above ground because of the permafrost and the cold temperatures. And now, you know, the concern is, again, a lot because of politics, much like in California, you know, the oil from the original fields has been declining. And so they're getting to the point where, because it's above ground, if they don't have a certain amount of oil in it, it can start congealing and the pipeline won't work. So that's part of why these ConocoPhillips, their Willow project and some of the other stuff is important to keep that oil flowing. Any other questions?
Any chance that you look also address the Gulf of Mexico?
Yes. Yes, it does. And it covers the evolution of the offshore industry. And what's fascinating, so I know we talked about Ohio today. So technically the first offshore drilling was in Ohio. So it was in the Lima field. And there's actually a man-made reservoir. It's called the Lake St. Mary's Reservoir in western Ohio. So there, it was originally built to feed a canal between the Ohio River and Lake Erie. And which that canal holds a lot of coals. But yes, so when they had the Lima oil boom, they were drilling around this reservoir, and then they had to flood at one point. So it flooded a bunch of these wells. And then they basically just started drilling in the water. And so they called them cribs. They would just drill, they had them kind of above, and then they use little pipelines to get the oil back. So that was kind of the first offshore drilling. Now, you guys may be aware, I've been seeing a lot of chatter about it lately, but another area of early offshore drilling was off the coast of California. It's Santa Barbara. And it was, they basically drilled off of piers. So they're building piers out into the ocean, drill, they produce a lot of oil. Of course, has been and remains some offshore oil production in California. But what a lot of people don't know is Santa Barbara, what a spectacular place. But there are natural oil seeps all over the place, seabed. And they come up in and then they wash up on shore and they create carbon. And I guess I've never stepped in one, but I guess they're like pretty sticky and hard to get off.
I was at UC Santa Barbara for 1 year, and every time I walked down to the beach, I came back, I had gasoline on the porch to clean my feet.
So,
Get away.
but that was part of the genesis of the environmental and kind of oil industry movement. Was in 1969 they had an oil spill out there. And of course, it was kind of overblown, but it did. It played a part in the formation of the EPA and so forth. But now, there are people in that area, including the governor of California, that want to shut the oil industry completely down. And these geologists are speaking at these things, and they're explaining, if you don't want the tar balls on the beach, it's bad for tourism. You can have responsible oil production, and that reduces the formation pressure and the oil spot. I don't think they're being listened to. People like you that know how the subsurface works, the politicians and the others that are just against the oil industry no matter what, will tend to get their way in places like California.
Well, it's a little after 1, so I think we'll call it quits, but thank you, Kent, very much.
Thank you.
So, I really enjoyed that. Did you send it over?
Sure.
I just rushed up from work.
What's your name?
I'm getting it. This is what we know. There's book about the real. Yeah, why you should. Listen to it. Yes, sir. As for years. Huge, totally different voices. A son.
Yeah.
This. The paragraph said.
Find out that
I just see this.
He was just giving an update on how well they were doing in But he did, anyway, if that says down there, AI generated, whatever. But he was really, it sounded like he was just talking. I heard part of it. The English, I mean, it was just an article. So I'll go, I mean, I'm more interested.
I just mentioned it. I was listening to one. This narrative from the person was, and the one voice was dad, and a different voice was, and a voice was this mom over here. And he was and the response, how many, I guess, how many years did he have?
He poured off. Jerry Spencer does sometimes perform. But anyway, If I told to go back a little.
I'm a homer. We have my way to go to see. Coming back.
So there's a lot of them. So you instead of bringing a laptop down there. My wife wants it's easy to roll out of bed. Yeah. So it's I'm trying to get that's a lot of that's a lot of money out Let's just pull them out. It's like, yeah.
You better do save our money anyway. My favorite book is from natural gas. It's real fire. So you talk about actually you need to build so yeah, you want about that. You know, you're well, we can't build it. Was justified shutting this whole thing down those years early. And he did $2 billion. Yeah, and sold. And so that's why also say shut down. Not only like okay. So it makes it more expensive. You can see how that's playing out there. So it's like the base. Yeah.